Alright everyone, welcome to video lesson 5.3. This is called Finding Unknown Measures in Similar Figures. We have skipped lesson 5.2 for this round. The expectations, I would like for you to take notes on each slide. You will be able to use a calculator for this lesson. When you come to class tomorrow, please bring your notes, and any question marked class discussion, please complete it and have it with you for tomorrow. And along the way, if you have any questions, write down the time of where we are in the video, and we'll address your questions tomorrow. Okay, so today there are 5 slides to this video, and we're currently on slide 1 of 5. Okay, here's slide 2. And no, let me take this. Thank you. Thank you. Slide 2, the central question for this lesson is, what information do you need to know to find the dimensions of a figure that is similar to another figure? Well, let's take a look here. You're given the red rectangle right here on the grid. To find the blue rectangle that is similar, it has one side, -1, -6, so that's here where my cursor is. 2, 5, -6, and that's right here where my cursor is moving. Write and label the vertices. So what we need to do is find pretty much the other side, because if I know how tall this rectangle is going to be, I know the other side is going to be just as long. So from here, where my cursor is at -1, -6, to 5, 6, since we're parallel to the x-axis, I'm going to look at the x-coordinates. From -1 to +5 is 6 units, and we can just count them from here. 1, 2, 3, 4, 5, 6. So I know the length of this figure is 6 units. So all I need to figure out now is how tall the rectangle is. Well, how wide is it if I look at the red shape from -6, -4 to -3, -4? Well, again, we can count boxes. If I'm starting at this point, 1 box, 2 box, 3 boxes. So I know from left to right the distance is 3. So if I'm comparing length to width, I have, nope, that's wrong, I'm sorry. We could do length to width, actually. All right, I just need to figure out the height here, or the width. So if I start, down here at -6, -4, I just want to count boxes up here to -6 too. So 1 box, 2 boxes, 3 boxes, 4 boxes, 5, and 6. So this side measures 6. So if I'm looking at length to width, I'm looking at 3 to 6. The length is 3, the width is 6. So here, my length is 6. I don't know the height. I don't know how tall I should make this line, so that's going to be x. So I used the cross product to solve. 3 times x is 3x. 6 times 6 is 36. So to isolate the variable, we divide both sides by 3. So x equals 12. So that means from this point here, from this point, -1, -6, I need to go up 12 units. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oops, that's in the wrong position. Okay, so here's my 12th spot. Sorry, I just counted wrong a second ago. So from -1, -6, I counted straight up 12 units. So my point is right here where I'm coloring in. So to name that coordinate, I start at 0, 0. I go left 1 unit, I'm at -1, and I go up 6. So I'm at -1, 6 would be the coordinate here. So I know my line is right here. And I know this line here on the right is going to be just as long. And then I'm going to connect these two. So if I need to find all the other coordinates, I can now name this point. Starting at 0, 0, I'm at 5, going on the x. Then I'm going to go up to 6. So this point is 5, 6. And I know this point down here on the bottom right and that point on the bottom left. Okay, let's move to slide. For this slide here, what I'd like for you to do is take the sheet of graph paper, or take a sheet of graph paper and plot at minimum the original rectangle out. If you have any questions on how I came up with the new points, write these new points down and we'll go over in class again tomorrow. Alright, here's slide 3 of 5. This is going to be a lot easier to look at because there's just a lot less going on. And the question is, the red and blue rectangles are similar. Find the length of the blue rectangle and explain your reasoning. So this is what we're looking for here. We know length to width, and then length to width. So length to width, I want to solve for x. So remember, the order of how you write the ratio of the first set of fractions, okay, pumpkin, you're going to write the ratio to the second set of fractions. So I'm going to do 1.5 over 0.57, so length, width. So I'm going to do this next one in the same order, x over 1. Okay, so if you need a calculator, go ahead and get one. So what we're going to do now is use the calculator, and we're going to multiply 1.5 times 1, so that gives us 1.5, and we're going to set that equal to 0.75x. So the goal is to isolate x, so we divide both sides by 0.75. So you can use your calculator for that. 1.5 divide 0.75, and I get x is equal to 2. So that means this missing side here has a length of 2. Okay, and for this slide, 3 of 5, I would like for you to draw these two rectangles out and then show the work that I showed you on the right hand side. Oops, sorry about that. Alright, here's slide number 4. If I move too quickly through slide 3, just go back, rewind a little, and pause it until you're all set. So slide 4, the two triangles are similar. We're going to find the value of x. So I'm going to show you how to do this one a slightly different way. I'm going to compare original length to new length. So I'm going to call this original and I'm going to call this new. So I'm going to write this as 6 compared to 9, and then original length 8 compared to new length x. Okay? So what I'm going to do is I'm going to use the cross product. Sorry if you guys hear noise in the background, it's just Dante running around. I'm going to multiply 9 times 8 and get 72. And I'm going to set that equal to 6 times x is 6x. At this point, why don't you pause, copy down what I have so far. That way you can keep along and copy the rest of the notes. Alright, so from here, my job is to isolate x. So I'm going to divide both sides by 6. So these cancel. And if I divide both sides by 6, I get an answer of 12 is equal to x. Okay, and this is just the same thing that I just wrote, just neatly typed up. And finally, here's Here's slide number 10. What I'd like you to do here is not necessarily copy the word problem down. We're just going to read it. Draw yourself 2 triangles. All right, draw yourself triangle 1. Label H for height and the base or the length of the length of the shadow, 15 feet. And then again, you can just draw yourself a small triangle like this. You can label the one side 6 feet and the bottom side, which would represent the shadow, 3 feet. So you technically just need 2 triangles, one slightly bigger than the other. So what are we doing here? A person is, oops, I didn't want that. A person is 6 feet tall and casts a 3-foot shadow. So 6 feet tall, 3-foot shadow. A nearby palm tree casts a 15-foot shadow. Here's the shadow. What is the height of the palm tree? So missing part here. Assume the triangles are similar. So you're going to create your proportion, and in class we'll go over this and discuss. All right, guys, I will see you all tomorrow.